All right. Okay, guys. We're going to do now problem 2, example 1. Now this says Mr. McSparron's car is driving 45 meters per second at time equals 0. As he slows down to a stop sign, his velocity changes at a constant rate from 45 meters to 0 meters per second over a 9-second time interval. Okay, so if we look at this, so first off, I know that I'm going to start off here, all right, where it's 45 meters per second and t is 0. Well, I know that t equals 0 is like right there, okay, but I don't have any numbers here yet. All right, so what I need to do is I need to number this. So I'm going to go up to 45. And it looks to me like I'll bet you if I just number this by fives, it'll work. So let's go like 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I think that's going to be perfect. All right, now I'm going to do a different color. Let's do purple. And so I know that it has to be where time is 0 and velocity is 45. So that's going to be right there. So that's my starting point. Now I know that at the end of this all, I'm going to be going 0 meters per second, and it's going to take 9 seconds to get down to that. So if I look over here, all right, so I know that after 9 seconds, so that's going to be like right there is 9 seconds. I've got to be going 0. And actually, I could even do this. I could write in 0 there. Okay, so my new point is going to be at 9 seconds and 0 meters per second. All right, so I've got my start and my finish, and then I'm just going to connect the dots. Okay. Now, so that's all you got to do for the graph, guys. So like that's part A. Check. That's done. Just make sure you number it and draw the line in the right direction. All right, now it wants to know the acceleration. All right, so remember, the acceleration, I calculate that by finding the slope. All right, so right now, I'm going to find the slope of this thing. So remember we said there's a couple different ways to do that. So the first thing I'm going to do is I'm going to use the equation. So I'm going to use this equation. Vf minus Vi over Tf minus Ti equals slope. And I know that so I'm going to find my Vf, my Vi, my Tf, my Ti. Okay, so remember that Vf, that's final, or the end. Okay, so my final at the end, my velocity was 0. All right, initial, so VI is initial. That means beginning. Beginning. All right, so at the beginning, my velocity was there, 45. Now my time at the end, okay, remember that's right there. All right, my time at the end was 9. My time at the beginning, so here, right there, was 0. So now I'm just going to plug those in. All right, so V, so remember, like, I'm going to put, oh, wait, VF goes with VF. That's 0. Okay, VI goes with VI, so that's 45. TF goes with TF, so that's 9. And then finally, TI goes with TI, so that's 0. So I'm going to get negative 45 divided by 9. And if I take that and do it here, it's going to be negative 5. Remember, this is meters per second, or you could write it as meters per second squared. I'm really okay with either one. Now, remember, there's also a way we could have done this. We could have done rise over run. All right, so just real quickly, I know that my rise is going to be from the beginning down So that's going to be negative 45. Remember, because I go from 45 down to 0. So negative 45 for my rise. And then I'm going to run over 9 spaces. All right, so then I've got rise over run is going to be negative 45 divided by 9. And we can see that that is the same as that. Okay, so, oh, that's what I did. Undo. Sorry, guys. There's negative 45 over 9. Okay, so whichever way is easiest for you. Hey, and if you're a super student, maybe you do it both ways just to check and make sure that you're right. Okay. Now, finally, it wants me to draw a motion diagram. Let's do it black. Okay. All right. So what I know here is that the car is slowing down, right? Because it's starting off fast and then it's slowing down to slow. All right, so all I'm going to do is I'm going to go long lines that are going to gradually get shorter and shorter, and that's pretty much enough. Now it wants to know the direction of the force, so my force is going to go against the motion. If it was speeding up, it would go the other way. All right, there we go, guys. Now you try the next one on your own.